Buildings that reach for the sky, bridges that stretch across vast landscapes, and dams that hold back unimaginable forces of nature. But here's the thing about building big: when things go wrong, they go really, really wrong. We're talking billion-dollar engineering mistakes, catastrophic miscalculations, and the kind of oops moments that make you want to bury your head in a blueprint and never come out. We're going to revisit some of history's biggest engineering disasters, from leaning towers to collapsing bridges, and figure out exactly what went wrong. So, buckle up, grab your hard hat, and get ready to explore the fascinating, sometimes terrifying world of construction gone wrong. Let's get started. Our first stop takes us to sunny Italy. Picture this. It's the 12th century, the Renaissance is starting to bloom, and the city of Pisa is feeling pretty good about itself. To show off their newfound wealth and status, they decide to build a grand bell tower, something that would put Pisa on the map. Construction begins, everyone's excited. And then, just 3 stories in, someone notices something's a little off. The tower is leaning. Now you might think this would have been a stop the presses moment, right? Turns out Pisa sits on a foundation of soft, unstable clay and sand. And those medieval engineers? Well, they kind of forgot to check that part out. They just started stacking marble like it was nobody's business. As the tower grew taller, the weight of all that stone started to do its thing. The foundation shifted, the lean got worse, and pretty soon the whole city realized they had a bit of a problem on their hands. Over the next few centuries, they tried everything to fix it. They adjusted the weight distribution. They added support beams. They even prayed to the patron saint of straight lines. Okay, maybe not that last one. But the tower just kept on leaning. It wasn't until the late 20th century, armed with modern engineering know-how, that we finally figured out how to stabilize the leaning tower. They used a technique called soil extraction, basically removing small amounts of soil from beneath the leaning side to encourage it to settle back into place. And you know what? It worked. The tower is still leaning, of course, but it's no longer in danger of tipping over. It's July 17, 1981. And inside the Hyatt Regency Hotel in Kansas City, Missouri, hundreds of people are enjoying a night of music and dancing. But at 7:05 p.m., that joyous atmosphere would be shattered in an instant. 2 suspended walkways, packed with spectators, suddenly gave way, crashing onto the crowded atrium floor below. The collapse sent shockwaves through the nation. 114 people lost their lives and over 200 were injured. It was, and remains, one of the deadliest structural failures in U.S. history. A stark reminder that even in the modern era, engineering mistakes can have devastating consequences. But what caused this horrific collapse? Was it a fundamental flaw in the design, an act of nature? The original design called for a single, sturdy support rod to hold up each walkway, but during construction, the design was altered. This change, seemingly minor on paper, doubled the load on the support rods, and tragically, no one caught the error in the recalculations. The Hyatt Regency disaster sent shockwaves through the engineering world. The investigation revealed not only the fatal design flaw but also systemic issues with communication, oversight, and professional responsibility. The disaster led to sweeping changes in building codes, engineering ethics, and the way structures are designed and reviewed. The Tacoma Narrows Bridge, when bridges take flight. Now let's talk about bridges, those ribbons of concrete and steel that connect us across rivers, valleys, and even entire seas. Building a bridge is no small feat. It requires a deep understanding of physics, material science, and the often unpredictable forces of nature, and sometimes even the best-laid plans can go awry. That's exactly what happened on July 1, 1940, when the Tacoma Narrows Bridge opened in Washington state. It was a thing of beauty, sleek, modern, and at the time, the 3rd longest suspension bridge in the world. The locals were proud, calling it Galloping Gertie because of the way it would sway gently in the wind. But this wasn't your typical bridge sway. This was different. This was unsettling. See, from day one, the Tacoma Narrows Bridge had a bit of a shimmy problem. Even in light winds, the bridge would ripple and undulate, sending waves rolling down its length. Engineers at the time weren't overly concerned. They figured, hey, bridges are supposed to move a little, right? It's called flexibility. But they'd underestimated one crucial factor: aeroelastic flutter. This is a fancy way of saying that the wind, flowing over the bridge's streamlined design, wasn't just pushing on it, it was actually causing the bridge to vibrate at its natural frequency. And the more the wind blew, the more those vibrations amplified, like pushing a kid on a swing at just the right moment. On November 7, 1940, just 4 months after it opened, the Tacoma Narrows Bridge met its dramatic end. Gale force winds whipped through the Narrows, sending the bridge into a frenzy of twisting and writhing, and then, with a groan of steel and a roar of snapping cables, it gave way, collapsing into the Puget Sound below. The Tacoma Narrows Bridge disaster forced a complete rethink of how bridges were designed, particularly when it came to aerodynamics and wind resistance. Imagine waking up one morning, looking out your window and seeing a building lying on its side. Not collapsed, not in ruins, but just chilling out, taking a nap. That's exactly what happened in Shanghai, China in 2009 when one of the buildings in the newly constructed Lotus Riverside complex decided it had had enough of standing upright. Now you might think a building falling over would involve a lot of noise, dust, and general mayhem, right? Not this time. The building, a 13-story apartment block, simply tipped over onto its side, remaining remarkably intact. It was like watching a giant Jenga tower topple over in slow motion. So how does an entire building just decide to take a nap? The answer, as is often the case in construction failures, lies underground. You see, while they were building the Lotus Riverside complex, they decided to also put in an underground parking garage. Makes sense, right? Plenty of parking, happy residents. But here's where things went sideways. The soil they excavated for the parking garage, they piled it up right next to the newly built apartment building. Like, right next to it. We're talking a mountain of dirt putting immense pressure on one side of the foundation. Now, add in a period of heavy rainfall, which saturated the ground and made it even more unstable. It was a recipe for disaster, and disaster is what they got. The pressure from the soil combined with the weakened ground caused the foundation to give way. The building didn't collapse, it just rotated. 5. The Sampung department store collapse, a preventable tragedy. Our final stop takes us to Seoul, South Korea, where a bustling department store became a symbol of corporate greed and the devastating consequences of cutting corners. It was 1995 and the Sampung department store was a shopper's paradise. 5 floors packed with boutiques, restaurants, and everything in between. But beneath the shiny facade, a disaster was brewing. You see, the Sampung department store wasn't supposed to be a department store at all. The original design was for a 4-story office building. But during construction, the owner, driven by a desire for more retail space, decided to add an extra floor. Oh, and he also wanted to put in a skating rink, because why not, right? Now, adding an entire floor to a building designed for something else is a pretty big deal. It requires significant structural reinforcement to handle the extra weight and stress, but those reinforcements, yeah, they kind of forgot about those. Actually, it was less about forgetting and more about actively choosing not to do them, because, those things cost money. And it wasn't just the extra floor. To accommodate escalators, they removed several load-bearing columns, those sturdy pillars that hold the whole building up. Engineers warned them repeatedly that these modifications were incredibly dangerous, and that the building was at risk of collapse. But their warnings were ignored. The owner, blinded by profit, didn't want to hear it. On June 29, 1995, the inevitable happened. Cracks began to appear in the ceiling of the 5th floor. Management, finally realizing the gravity of the situation, ordered an evacuation. But it was too late. In less than 20 seconds, the entire structure crumbled like a house of cards. Over 500 people lost their lives in the Sampung department store collapse, making it one of the deadliest peacetime building collapses in history. It was a tragedy that could have been avoided. So there you have it, 5 epic construction fails that taught us some incredibly important lessons. We've seen how ignoring soil conditions can turn your dream tower into a leaning nightmare. We've learned that even the smallest design changes can have catastrophic consequences, and that cutting corners on safety is a recipe for disaster. But amidst the rubble and the tragedy, there's a glimmer of hope. Each of these disasters, as devastating as they were, left behind more than just debris. They left behind lessons in physics, material science, ethics, and the importance of getting it right. Today, engineers use these hard-won lessons to build stronger, safer, and smarter structures.